This video is the beginning of Unit 7, and we are actually going to be doing 3 of the flaps today from the flipbook. We are going to be starting with the Rules and Reflections tab, and then we're going to move down and do the vertical shift and horizontal shift, so the last 2. We're going to save the compressions for next video. So first, go to the first flap, the Rules and Reflections. So that is, bear with me because my flipbook looks a lot different than yours. So that is towards the top up here. You need to know these rules. These are review from Algebra 1, so make yourself familiar with these. Today we're going to be doing the vertical and horizontal shifts along with the reflections. So really the first 6 boxes up here. So make sure you know those. So we're going to start with the reflections, which are down here. So if you want to make a little note to yourself, when you are reflecting across the x-axis, put a little note, you're going to negate the y's. So if you are in a coordinate grid and you are just asked to reflect a graph over the x-axis, you're simply just changing the signs of the y coordinates. The x's stay the same. And then it's the opposite for reflecting across the y-axis. You're going to negate the x's. Now what that will look like if they give you an equation instead of a graph, well, you could simply just graph it and then change the coordinates and then come up with the equation, which might actually be a little harder to do than to just know that you're going to change the sign of the y and then get y alone, or you're going to change the sign of all of the x's. So it just depends on what your equation looks like. So now if you look down at the second part of that tab, the rules and reflections, which for me, sorry, that is at the bottom of this page, so you should be on this page right here. The first example asks you to reflect across the x-axis. So to reflect across the x-axis, here's what I would do actually in my head. I would take the equation here, and I'm going to negate the y. So I'm going to do this. Well, we then want to get y alone. Remember, this is really a -1. So if I divide -1 over to the other side, I can just simply move the negative sign from the bottom to the top, and that's what you get here. So really what you're essentially doing is you are taking whatever is on the right-hand side of your equation and changing all of the signs because you're dividing through by a -1. Now, to go over the y-axis, you're simply going to just negate your x. So if you look at this equation, you're going to find where you have an x. Now, sometimes there's more than one x. Like there could be an x squared and an x to the first. You'd have to negate them both. You'd have to negate all x's on the right side only. If there's a number that doesn't have an x with it, you don't change his sign. You simply negate the x. So you'll notice what they did to this equation was they took the x and changed it from a positive to a negative. And that's it. That's all you do for reflections. You just have to know if you're going over the x-axis, you negate the y and then get y alone because it will be negative. If you're going over the y-axis, you just negate the x's. And remember, if it's negative to start with, it then turns positive. So that's it for reflections, and then you got to know your rules, which we will focus more on right now for at least the horizontal and the vertical shift. So now go back down to the second to last tab where it says vertical shift. So that for me is the top of my page 5. So you should be looking at something like this, the vertical shift. So the vertical shift, if you're going up or down, you simply just add or subtract a number to the end of the equation. It is not in the parentheses with the x. It is not attached to the x in any way. It is simply just added or subtracted at the end of your equation. So for this one, we wanted to move up 5, so we just add 5 at the end of our equation. For this one, we wanted to move down 6, so we just subtract 6 to the end of our equation, and that's it. So now if you do the you try these, which for me, let me turn this down because this keeps making that noise. So for me, it is the bottom of page 4, the you try these. Come on. So yours should look like, for some reason this isn't working, this. So they want us to shift this graph up 3. You'll notice the original was y equals x to the 2/3, and they want us, if you notice the difference, was the +3 at the end. It was not inside with the x, it's not attached to the x at all. So therefore, I'm just going to shift this whole graph up 3. So simply count and move. You got to move enough points so you get the general shape. But 1, 2, 3. And then maybe I'll move, I don't know, this point up 3. 1, 2, 3. And this one looks nice. 1, 2, 3. And then it's going to look exactly the same, except just shifted up 3. Notice in the second you try these, here's the original graph. They want us to do the following. You'll notice a -4, which means I'm just going to move it down 4. So pick some points. I'll start with this one and move it down 4. 1, 2, 3, 4. And then this one. 1, 2, 3, 4. Maybe one more. That's not very nice. Well, okay, that's kind of enough. But it should look, this is kind of not drawn the very best. It should look like it's trying to get to -4 because it was trying to get to 0 here. So if I move down 4, I'd be going to -4. And then it's going to go up. It should go up at the same rate. I probably should have maybe moved this one down 4 right here. But try to make it look like it should. Okay, the next one we're going to go to now is horizontal shift. This is the one that's weird. This is the one that's like the opposite of what you would think. So you should be looking at the page that looks like this. It is the very last tab. So the horizontal shift, this is if the number is connected or attached to the x. So it will either be inside parentheses with the x or inside absolute value signs or inside or underneath the radical sign, but it has to be like attached to the x. It has to be part of the x quantity. So in this particular example, you will notice, and to come up with the rule, you could graph both of these and see what happened. Well, if you graph the original y equals absolute value of x and then y equals the absolute value of x minus 4, you will notice that it actually ends up moving to the right 4. So it's kind of the opposite of what you would think. You would think it would move left 4 because it's a -4, but you're going to do the opposite. Same thing down here. If you were to graph the square root of x, you would get this graph. And then if you were to graph the square root of x plus 6, it would actually, you will notice, it will move left 6. So the horizontal shifts are kind of the weird ones where they kind of do the opposite of what you would think and the opposite of what the vertical shifts do. The vertical shifts are very straightforward. If it's a plus 6 at the end, it moves up 6. If it's a minus 6, it moves down 6. But horizontal shifts are the opposite. If it's a -4 that's attached to the x, you're moving right 4, sorry. If it's a plus 6 that's attached to the x, you're moving left 6. So it's kind of the opposite of what you would think. So now go to the you try these. So that is down here. So for this one, here's the original graph of y equals x squared, and they want us to graph this function, which is taking your x squared, but you're adding in a 4 with the x. Remember, you would think a plus 4 would move right 4 because that's the positive direction horizontally, but you're actually going to move left 4. So you're going to take a few points and move them left 1, 2, 3. So the vertex would go there. And then you should, for me, I really can't see these, so I'm just going to try to like guess. I mean, you should count because you can see your graph, but it'll look something like that. So just pick another 2 points, move them left 4, and connect them. This one. So same thing. You'll notice that this is called the parent function. It's like the starting function. And we want to graph this function. Well, it is very similar. The only difference is that inside with the x, there's a -5, which means I'm going to move right 5. I'm going to move every point right 5. Again, you just have to pick enough so that you kind of see what's happening. So I'm going to try my best. I think yours obviously is much easier to see, but that is the point 1, 1. So I'm going to stay at up at 1, but I'm going to move right 5. So it would be over here at 6. So something like this. And again, it's going to look exactly the same except just over 5. So same thing for this side. This looks like the point -1, -1. So if I move it 5, that would be -4, -1. And again, it's going to look exactly, you should move a few more points. But oops, that was a bad line. But you get the idea. That actually should not have overlapped. It should have gone more straight down. So just do your best at counting. You can obviously see the graphs better than I can on the smartboard. And the last one, so you'll notice here's the parent function. That's your starting function. And the difference between that equation and this one is that there's -5s inside with the x's. So that means we are moving right 5. So you're going to move everything to the right 5. So again, I cannot see these numbers on here, but you're going to move everything. You're going to basically take this graph, shift it to the right 5. 1, 2, 3, 4. Maybe this is 5. So it's going to go dip down and then up. Whoa, that was terrible. And then down and then up. Again, you should actually move points to the right 5 since you can see your graph a little better than I can. So that's it for horizontal and vertical shifts and also for reflections. So we will recap this in class, but again, these should all have been review from Algebra 1.